Today we will be going over the real number system for section 1.2. Let's start with vocabulary. What are natural numbers? Natural numbers are also known as counting numbers. And they are only positive. So, for example, natural numbers would be 1, 2, 3, 4, and etc. Now let's go to whole numbers. Whole numbers are natural numbers plus 0. So that would look like 0. So our whole numbers look like 0, 1, 2, 3, and etc. Now, integers. Integers are whole numbers plus negative natural numbers. So, for example, those numbers would be -3, -2, -1, 0, 1, 2, 3. And we put the dot because there will be the negative numbers before -3 as well as the positive numbers after the 3 right there. So those are our integers. Now, rational numbers. Rational numbers are any number that can be written as a fraction. So any number that can be written as a fraction. If we can write it as a fraction, we know it is a rational number. So, for example, we have the number -8, 2/3, 2.6, 15/9, etc. Those are examples of rational numbers. Now, irrational numbers are a number that cannot be written, a number that cannot be written as a fraction. So a number that cannot be written as a fraction. And let's also note that non-repeating and never-ending decimals fall in this category. So those would be non-repeating and never-ending decimals. So some examples would be, some examples of this would be pi, the square root of 5, and other numbers as such. Now, real numbers. Real numbers are all of the numbers listed above. All of the numbers listed above are real numbers. Okay, so let's go ahead and fill out this little diagram, and it will kind of help us organize what we just put in writing above. So let's diagram the real number system. So let's go ahead and label it real numbers. And this will be very helpful for the quiz. And what we're going to do with real numbers are divided into two sections. We're going to deliberately put our line, not in the halfway, but maybe 3/4 of the way across. So we're going to divide this box, and on the left, or I'm sorry, let's start on the right. On the right, we will have what are called irrational numbers. So we will write irrational, and on the right, we will start with rational. So rational, and let's go ahead and we're going to put our next box. So within rational numbers, so real numbers, all rational and irrational numbers are real numbers. Well, when it comes to rational numbers, let's go ahead and put our next box, and that will encompass integers. And within integers, you will find your whole numbers. So you will find your whole numbers. So let's go ahead and make a box for whole numbers. And within your whole numbers, you will find your counting numbers, which are also known as your natural numbers. So we could put natural, which are also counting numbers. So within real numbers, all real numbers, they will either be rational or irrational. And within rational numbers, you have integers, and within integers you have whole numbers, and within whole numbers you have natural numbers. So you can see how that looks in the real number system. For this section, you will insert these signs, the greater than or less than sign or the equal sign, into the appropriate space to make a true statement. If necessary, graph each number on the number line. So we have -10 and -100. Which one is greater? Well, remember, we have our number line here. So if we had our number line right here, and we have 0, +1, +2, and then we have -1, -2. I'll just go -3. So if we were to have these numbers on the number line, we would have -10, probably somewhere down here, and then we would have -100. Well, remember, the further to the left we go on the number line, the smaller the number gets. Therefore, it is safe to say that -10 is the greater number compared to -100. 29. -200 and -20. Again, if we were to plot them on the number line, we would see that -20 would come first right here, and -200 would be down there. Therefore, -20 would be the greater number. So the way this would read is -200 is less than -20. Number 30. If we have 0.9, so we know 0.9 would be about right here. And we know that 3/4 is 0.75, which is right there. We know right there that 0.9 is greater than 3/4. Let's go to number 31. Number 31, we have 2/3 and 0.5. Well, we know 2/3 will be right about here. Oops, I erased that. Let's undo that. So we know that 2/3 will be right about here, and we know that 0.5 is about here. Therefore, we can say that 2/3 is greater than 0.5. Negative 1 and 5/6 versus negative 1 and 2/3. So we have negative 1 and 5/6 is about right here, and negative 1 and 2/3 is right about there. It's safe to say that negative 1 and 5/6 is less than negative 1 and 2/3. Just a reminder, the bigger side of that symbol goes towards the bigger number. Then we have negative 1 and 59/10 and negative 1 and 3/4. Well, we know negative 1 and 59/10 is going to be, I'll use this arrow that's up here, all the way down. Whereas negative 1 and 3/4 is going to stop right about here. Therefore, it is safe to say that negative 1 and 59/10 is definitely less than negative 1 and 3/4. Now let's go ahead and go to number 34. Number 34, we have two negative numbers. We have negative 51 and negative 50. We know that negative 51 will be further to the left of the number line. Therefore, we know it is less than. So negative 51 is less than negative 50. Number 35, negative 20. Now notice that negative 20 is in what's called absolute value bars. Those absolute value bars always make the number positive. So let's bring out that negative 20, and really we're looking at a positive 20 there. So the absolute value of negative 20 and negative 200, we know that that absolute value of negative 20 is actually 20, and that is definitely greater than negative 200. Number 36, the absolute value of negative 5 will definitely be greater than negative 4. Then we have 0 and the absolute value of 0. Those are definitely equal. We have negative 1, absolute value of negative 1, and absolute value of positive 1. Those will be equal because remember that negative 1 is really a 1, and that 1 in the absolute value bars is also a 1. So they're equal to each other. We have the absolute value of 2/5 and the absolute value of negative 2/5, which equals 2/5. Therefore, those are equal. Let's do number 40. The absolute value of negative 2 is really 2. Absolute value of negative 3 is actually 3. So therefore, 2 is less than 3. Number 41, negative 500, and the absolute value of negative 50. We have the absolute value of negative 50 is actually 50. Therefore, negative 500 is less than the absolute value of negative 50. We have the absolute value of negative 12, which is actually 12. So therefore, the absolute value of negative 12 is, well, we know that 24 divided by 2 is also 12. Therefore, these are both equal.